So let's take a look at problem 5 from the practice exam. So it says find the limit. So most of these limits you can do just by plugging in. So remember our very useful fact that if you have a normal expression that you can just write down as an equation without brackets or without defining it by cases, then it's continuous everywhere it's defined. And being continuous means that you can just plug in when you want to find a limit. So this first one, A, is really easy. What do? We just plug in 0. So this is cosine of that x becomes a 0, and then I've got sine of 0. So this is just cosine of 0, and cosine of 0 is 1. Okay, so A is 1, and what about B? So what happens if we just plug 16 in? Oh, there's a problem, right? So if I plug in 16, I get a 0 down in the denominator. So what I've got to do is I've got to do this trick of rationalizing the numerator. So I multiply in 4 plus s over 4 plus s. I should be saying the square root of s. And what does that give me? The difference of squares makes this 16 minus s on top. And on the bottom I've got s minus 16. And then times this new stuff, 4 plus the square root of s. And okay, so look, this thing in red brackets is just the negative of this thing, right? Those things are just negatives of each other. And so this is equal to minus 1 over 4 plus the square root of s. And so now what happens is s goes to 16, I can just plug in. I can just plug in at this point. So I get minus 1 over 4 plus the square root of 16. And so that's just minus 1 over 8. Alright, and now let's look at C here. Maybe I should switch colors so it doesn't get so busy. Alright, so you've got a polynomial. And let's check to see if we can just plug in. I think I meant to make it so that you couldn't just plug in, but I think I messed up, and actually you can. So if you plug in 3, then you pretty clearly get 0 in the numerator. And what happens in the denominator? You get 9 plus 6 minus 3, which is a perfectly good number. So this is just 0 over 12, and that's just 0. So just plug in, and it turns out to be 0. And this is using a rule about the horizontal asymptotes of rational functions, which you may or may not remember. The rule is if you have a ratio of polynomials and they are the same degree, so here they have the same degree on top and bottom, the degree is 2, then the limit as x goes to infinity is the same as the limit as x goes to infinity of the leading terms. So this is just the limit as x goes to infinity of the leading term on top. That means the first part of the polynomial is x squared. It's the same thing down here, and this is 1, so this is just 1. Okay, so D is 1, and that's how you do that question.